The point of this discussion is going to be to talk about how a device called a capacitor works. So a capacitor is something that's used to store electric potential energy. We use it in a lot of different things, and I want to give two examples. The flash in a camera, and also the rectifier in your cell phone charger. And what a capacitor consists of is two parallel metal plates. Typically these are rolled up, and in between them is some sort of insulator. What I've drawn here, we're assuming there's air insulating between them, but all sorts of things can be there. Mica, rubber, oil, something called an electrolyte, glass, a very toxic chemical called a polychlorinated biphenyl. There's lots of things that can go in there. And the job is to keep the charges separate. Although, as we've seen with lightning rods, you can get dielectric breakdown in any capacitor. And that's when you've put too much charge, too strong an electric field, and you get a spark between the plates. So what do these two plates do? Well, let's hook up a battery. So I'm going to hook up the positive side of my battery to this plate, and the negative side of my battery to this plate. And we'll talk about batteries quite a bit. They were invented in the 1790s by an Italian guy named Alessandro Volta. And basically, there's two chemical reactions going on simultaneously. The one at the positive end actually uses electrons up. So what happens is the electrons in here get used up, and electrons actually flow into the battery, and it starts taking electrons away from this plate. That makes this plate positive. Now, how does that work without charging up the battery? At the exact same time, there's another coupled chemical reaction going on at the other end, which is producing electrons. So we get this plate at exactly the same time becoming negative. And at any given time, there's the same number of positives and negatives on the two plates. So what has this done? It's actually stored energy. The battery had chemical energy. There were some reactants that were consumed to make products, and that did work. And it moved electrons away from positives. That's where they want to be. There wasn't enough electrons here, and the battery took more away. And it forced those electrons near negatives, where they really didn't want to be. So it's kind of like the anti-Robin Hood. It stole from the electron poor and gave to the electron rich. And that stores energy. So that energy is now available for use, just like this textbook, when I left it. I'm doing work on it, energy is being stored. It's available for later use. So what do we use it for? Well, the most common example that at least kids of your age can remember, in a decade or so this won't be that common, is the flash on an old disposable camera. So you probably haven't used one in years, but if you recall, you'd wind the film, and then you'd press a little button, and there'd be this whining noise, and you couldn't actually take your picture until an orange light started flashing faster and faster and finally was steady. Well, what was happening during that time was a capacitor was being charged up. And why did this have to happen? The only battery in those old phones was a single AA battery. And that battery didn't provide a quick enough flow of electrons to make the flash work. It would be like going up to a big water wheel at some huge industrial plant with a garden hose and just aiming at it and spraying it. So the thing's not going to move. So how do you make a battery power a flash, which needs to have tons of electrons flowing through it all at once. You wait. Just like we could take that garden hose, and instead of pointing it at the water wheel, we could fill up a dam, fill up a lake behind a dam. Eventually we'd have so much water there that when we opened up the floodgates, whoosh, it would definitely turn that wheel. That's what we do here. Battery charges up the capacitor. We have the flash bulb, which I'm going to model here as a light bulb. This gets hooked up to the negative plate. The shutter on the camera is hooked up to a switch. And when you want to take your picture, that switch closes, and a whole bunch of electrons all at once, whoosh, go back to where they want to be. It discharges the capacitor. And because that happens so quickly, just like when a dam fails and all the water rushes out, you get a lot of energy all at once, and that's why you get the bright flash. So that's what probably the most obvious use of a capacitor is. We also use them in something called rectifiers. And we're going to get into this more when we talk about the difference between direct current, which is caused by a battery, and it consists of electrons always leaving a negative and going into a positive, and alternating current, which is what comes out of the wall, and electrons first flow one way and then the other, and then one way and then the other. Your phone runs off batteries. The computer chips inside need the direct current, that comes from a battery. But you plug it into a wall. So there's got to be some way of changing this back and forth, speeding up, slowing down current into the steady stream of electrons a battery causes. And there's a lot of devices that do this. One's called a diode. It just basically says, no, you can only go this way and not the other way. But it doesn't smooth out the flow of electricity. You get this bumpy electric current. And what a capacitor does is it spreads out that electricity and smooths it out. How does it do this? Well, let's go back to the water analogy. If we talk about the Nile River in Egypt, the Nile throughout history, since biblical times, it would flood, wipe everything away, then be dry for a lot of the year. Flood, be too dry. Flood, be too dry. It had huge peaks in water and huge valleys and not enough water. So this went on until the 1950s, when Egypt had enough of it. They built what's called the Aswan High Dam. Well, what goes on there? There's a lake now behind the dam. So when there's lots of water coming, the dam traps that water. The lake gets bigger and bigger and bigger. And when there's not enough water going out, they release more of the water. So what that does is instead of having the huge peak in water and the huge lack of water, peak, lack of water, if you're at a peak, the dam just stops it. Doesn't let the water go that much. The lake gets bigger, the river doesn't really change. Now there's not enough water, let some of that lake go. Now it doesn't go to the bottom. You went from having this to this. That's what a capacitor does. It releases electrons when there's not enough. It stores electrons when there's too many. We'll talk more about that when we talk about different